So in this question number 1 of chapter 32 of HC Verma book, we are given that the charge passing through the cross section of a wire is given by At square plus Bt plus C, and we need to find the dimensional formula for A, B and C. And then they have given some numerical values of A, B and C, and we need to find out the current passing through that wire at time t equal to 5 seconds. For the dimensional formula part, the one thing that you need to keep in mind is that anytime we add two quantities, then these two quantities will have the same formula. So the dimensional formula of C will be same as the dimensional formula of Q or At square or Bt. Why is it so? Let's say I ask you a question, what is 13 seconds plus 3 meters? Now this is an insane question. You don't add seconds to meter. So the dimensional formula of this quantity C must be the same as the quantity that we are adding or subtracting to or making or equating to. So the dimensional formula of C is equal to dimensional formula of charge Q. And Q is given by current multiplied by time. Because the current is defined as nothing but the amount of the charge passing through a wire in a unit second. And therefore the dimensional formula of C is equal to dimensional formula of Q, and dimensional formula of Q is the dimensional formula of current into T or IT. Now coming to this dimensional formula of Bt will be the same as the dimensional formula of Q. So the dimensional formula of B will be the dimensional formula of Q by T, and Q is given by IT. So T cancels. Dimensional formula of B is I. In the same way, At square is equal to Q. Dimensional formula of A is Q by T square. Q by T square. Q is IT, current into time. And T square cancels. I by T or IT to the power of minus 1. In the second part of the question, we are given Qt is equal to At square plus Bt plus C. So there is a cross section of a wire, and we are keep counting the amount of the charge passing every interval of time, and that is the amount of the charge passing at time t. Now the amount of the current, how do we find the current? If we count that dq amount of the charge has passed in dt time, then this ratio gives the charge passing through that wire. So we can find it by differentiating this equation. 2at plus bt, and a is given to be 5, b is 3. At time t equal to 5, we can put t here. This is actually b only, because if we differentiate t with respect to t, it's b. So 2 into 5 into 5, 25 plus 2 into 5 into 5 into 5, 25 into 250 plus 353 ampere. So question number 2, we have an electronic gun is emitting electrons, and it emits electron at the rate of 2.0 into 10 to the power 16 in every second. What electric current does this correspond to? The electronic gun is firing electrons, and we know the charge on an electron. And what we are doing is we are counting. We have a stopwatch and we are counting. Every second we count 1 electron passes, 2 electron passes, and we are counting very fast. And hopefully if we can do that, we find that in every second we have 2 into 10 to the power 16 electrons passing through that. To find the current, we need to find how much charge passed through that cross section in unit amount of time, and that amount of the charge passed will be the number of electrons we counted multiplied by the charge on each electron, and we counted that 2 into 10 to the power 16 electrons passed. So the total charge that passed will be this multiplied by 1.6 into 10 to the power 19. 16 into 2, that is 3.2 multiplied by 16 minus 9 minus 3 to the power minus 3 amps.